Good morning, YouTube. So today we're going to start setting up to turn all this material into our LPS AlphaLocs. And we're going to be doing that in Fusion 360 on our lathe. Fair warning, this might be a long one. Welcome back to the channel. So these are our LPS AlphaLoc intercooler couplers. What they are is a quick disconnect coupling for intercooler and charge piping systems on forced induction vehicles. They're a quarter turn, quick disconnect, uses a double O-ring and a locking detent. It's just a very elegant solution to connecting charge pipes together and having a leak-free seal that's very strong and can hold a lot of pressure. We make them in a couple colors, a whole bunch of different sizes. Today, we're going to be making these inner weld ferrules. These are what gets welded to the charge piping in the system, and they're basically the core of the coupler assembly. This is where the O-rings are housed. They're actually two different pieces. One has pins, one does not. Pair is made in the machine in one operation. So this is my Haas DS30 SSY. It's a dual spindle lathe. So it has, well, main and sub spindles. It's got a 24 position tool changer with both axial and radial live tools. And it's got a Y axis. So it doesn't only have an X, but it's got Y. So you can actually do milling, interpolations and things with it. So it's a very capable lathe, capable of making complete parts from start to finish. And that's exactly what we're going to do today in Fusion 360. I said in a previous video, I lost all my programs due to a power surge or something. So I'm having to reprogram everything from scratch, but it's kind of a good thing because it allows me to increase efficiency on some of the things we regularly do. And it's forcing me to learn a new product that's very capable. So I'm looking at it as a blessing in disguise. But you know, it is what it is. Keep pushing forward. I'm going to get into Fusion now and I'm going to show you guys what I come up with. Okay guys, so I've spent some time programming and modeling these parts in Fusion now. So I have the parts modeled. So these are the weld ferrules themselves. They're modeled exactly the way they're going to be manufactured in the machine. I've also modeled the jaws, so the pie jaws that we're using to manufacture these parts. So basically these are going to be made out of a solid piece of tubing that's cut to a specific length. And by modeling all this stuff, all the different jaws that I'm using, I will be able to basically use strategies in this machine to hand parts off to one or the other spindle and be able to make these parts complete in a single operation. So I've modeled all my jaws accurately as they are in the machine. I've already had these jaws made previously, so I'm not going to go over making those. Basically, this is all the information I'm going to need as far as models go to manufacture these parts. Quickly, I'll show you what I got going on here. So this is the first set of jaws that it's going to use in the program. The material, well, the part itself actually, is offset. I don't know if you can see that in there, but from that surface to the back side of the part itself is basically like 25 thou. So 25 thousandths of cleanup left over off the blank part. From there, it's going to machine this front part of the ferrule. And then it's going to get transferred to the sub spindle, which is this side. And then it's going to machine this side of the ferrules in the sub spindle. And then it's going to transfer them back to the front spindle, but this one's going to be a dead stop. So basically this part will be even with the back of this jaw with no offset basically. So this will probably all make more sense later as we go through this, but that's the basics of the models that I need to manufacture these parts. So now we're going to jump over into manufacturing. So if we look at the manufacturing window here, these are all the tool paths I've created to manufacture this part in the lathe. Basically, if we go through the setups here, I have the first setup has the blank material. It has a little bit of material offset in front of the part. It's got a little bit of material offset in the back of the part. And it actually uses, well, I'm using just a dimension of my cut material for the length. And as long as I have everything offset and modeled correctly, that should be right. The other thing I'm doing here is, if you notice, my origin position is actually the back of the chuck jaws. What that does is allows me to have like a G54 work coordinate 0 as the face of my chuck jaw. Well, the face of the chuck itself, actually. So no matter what jaws I put in there, what differences they have, that surface is always going to be my Z0, my G54. So, and it'll be that going forward with everything I program from now on. As this outputs code, all of my Z positions are going to be like a Z positive position. So it might be a little weird for those of you, I'm saying this from experience, For those of you that like program off the face of a part, so Z0 is the face of the part, everything beyond that would be a Z negative number. A lot of people program like that, or even in CAM systems, they would program like that. So they would make that the origin. But what I'm doing is I'm making this the origin. That way, no matter, as long as I have the jaws modeled correctly and the parts modeled correctly, I never have to change that number. If we look at the next setup here, the next setup is the rear spindle. And I have the, so this is after the part's been handed off to the rear spindle, and I have the work coordinate set at the face of that chuck as well. So by modeling all this stuff correctly, what that allows me to do, when we go to do a subspindle grab, I know the exact distance that it needs to be from the face of the front chuck to the face of the rear chuck when I go to pick off a part. You know, let me take you to the machine and explain this a little better, because it's probably hard to understand here. So if we're looking in the machine here, the face of this chuck, this flat ground surface in between these jaws, is my G54Z0. I have the chuck or the jaws modeled accurately. I know the cut length of the part, so the part will be in there, a given cut length, and I've given myself 25 thousandths for cleanup on both ends of the part. And so basically everything will be programmed off of this Z0, and the part will be accurate, even though it's not outputting numbers in the code that you would recognize as far as Z positions. It's still going to function as if it was programmed off the face. It's just got a different work coordinate 0, basically. And what that allows me to do is, since I have this as my G55 so the face of this chuck is all my subspindle work 0 at a given position in the machine. Here, let's look at the offset page. If we look down here at my G54 and we look at the B axis, I actually have a huge negative number in there. And what that is, if this chuck face was touching this chuck face, like perfectly touching, that would be the offset from the B axis's home machine position. So as far as G54 is concerned, as our work coordinate system, these faces touching is B0. So anything beyond that is a B positive number in your G54 work coordinate. So by modeling all these jaws correctly, and I know that the part is sitting in a specific orientation and has specific lengths, I can now go to an exact number between these jaws and be able to pick off my part without any fancy touch-offs, without any making weird offsets. It's just going to know where it's at all the time. So hopefully that makes sense to you guys. When I pick off a part and bring this subspindle back to a position, I have a given position that I always basically machine at, which happens to be B negative 14 inches in this machine. It'll always go back to there. And with this spindle sitting at that B negative 14, the face of that chuck is now my G55 position. So if we look back here at the offsets, this number in G55 is now my Z0 for all my subspindle work on the G55 work coordinate. So this number is actually with B negative 14 from its home position, but that's where I always machine my subspindle work. So that number never has to change either. So this setup keeps things very simple if you program in this way, but it is so efficient, and it just takes all the guesswork out of everything, and I highly recommend it. So let me get back into programming, and I will show you guys hopefully a little better of what's going on here. Okay, so looking back at this program, we have our G54 work coordinate, which is over here, which is using this front jaw as its work coordinate system. Because I have all this modeled correctly, and if we show all of our ferrules here with the parts in there the way they're going to be sitting, you see that my subspindle grab here is using this back face as its positioning geometry. So we have our feed plane, which is 1/2 inch out from here, from this face. It's got an offset of 1/2 inch, and then it'll feed into basically its 0, which is the face of that chuck, modeled accurately in this entire assembly. So hopefully that kind of makes sense to you guys. These parts aren't super complex, but this handoff strategy is pretty cool. First operation here, this will be the raw material, just saw cut, held in the chuck. And then we're going to do a facing operation, a rough turning and a finish turning, a rough bore and a finish bore. We're going to do this groove that this O-ring groove here. All these tool paths up to this point are pretty self-explanatory, pretty simple. Then we get into this drill tool path. So this is our first live tool. I did this just as a single tool path, and then I patterned it. So now it takes that tool path and patterns it in 3 instances. If we simulate that, you can see that this thing drills on 3 different axes. So that's doing our basically pilot drill for those ream dowel pin holes. The next operation will be the reamer. So basically the same thing, the same type of operation, and then patterned. So this is now the reamer. So reaming the 3 holes. And that finishes our live operations and actually finishes the first operation of this whole assembly. Then we get into the subspindle grab. We look at this subspindle grab. It's using the back surface of that secondary spindle as its 0. Coming up, it already knows the distance between basically this surface and this surface, because if that number was 0, those would be touching, right? Because our B0 is those 2 surfaces touching. So if we look closely, we have 5 inches, 634 thou between those faces. And that should be dead accurate because we've modeled everything accurately. So we should be able to just go to that number without any issue. So hopefully that kind of makes sense to you guys. Then we're doing a subspindle return. Well, it's going to clamp the rear chuck, open up the front chuck, and then it's going to go to our rear machining position, which is a B-14, like it says right there. And then we'll flip over. As soon as I click this, we'll be flipped over and using the rear spindle. So this will be the subspindle, and the Haas's use like a mirror image spindle code to basically program this stuff as if it was the front spindle, which is pretty handy. But basically this is going to use that G55 position. So our G55 work position, which is the face of this chuck, is our origin at our -14, our B-14 work position. So again, we're programming everything off the back of the chuck, but none of these numbers are going to matter because it knows where everything's at. So again, we'll face on the rear spindle, rough turn, rough bore, finish bore, groove. So that's all on the rear spindle. I have a little manual code entry to clear chips here. So it just sends the machine home, gives me an MO for clearing chips, stops the spindle, so I can blow the chucks out before these parts hand each other back off. But what I'm actually going to do is I'll probably hopefully get rid of that. I'm going to play around with my spindle air blow nozzles and things and try to get these chucks to clean themselves out and with some realm of reliability. And then hopefully I can delete that little sub operation and I don't have to have an operator standing there and doing that little function. So we've now machined the rear, the back part of this assembly. And then we're going to do a subspindle grab again. So we go back to using our front position, which is now our jaw face for the dead stop jaws here. So now that's our Z, or our work coordinate 0 for G54. And we're going to hand this part back off to the front spindle, clamp both chucks on the part in both spindles. We're going to do our part off. So we have a part off operation here with both spindles clamped on the material. And then it's going to do a subspindle return, which will bring this rear spindle back to its work position. And then we just finish both parts. So we have our front chuck holding our finished, well, one side of the part's finished and then it's cut off. We have what's left of the material there. And then we're just going to go through the same stuff. So a facing operation, a rough turning, a finish turning, and then a finish bore. And then we're going to switch over and do the rear spindle, same thing. So face, rough bore, rough turn, finish bore. And that's the end of the program. So basically you'll put a blank of material in this lathe that looks something like that. And then you'll hit the go button. You come back to 2 finished parts. Weld ferrules will be done in a single operation. So I'm going to go through the G code on this. This is the first time I've done multiple handoffs like this in Fusion. So I'm going to go through the G code with a fine-tooth comb and see if I can find any errors that Fusion's outputting. I have a feeling I'm going to have to do some manual changing of opening and closing chucks. We can go through that here in a minute after I go through it. So let me do that and then I'll get back with you guys. So I'm sitting here touching off tools, and I thought I'd mention that one of the difficult parts about doing this main spindle sub-spindle type machining is that you need to use multiple tool offsets per tool. So I'll show you an example here. So I have you can see down there I've got multiple turn tools, both front and rear on the same tool position. I've got boring tools, front and rear, same tool position, and I'm going to use this part-off blade on both sides. So basically how you do that is, like, my tool 1, I have tool 1 offset 1 for the front, and I've got tool 1 offset 31 for the rear. So I've just picked an arbitrary offset number. This turret has 24 tools naturally, so I just picked in the 30s to be my secondary offset. So this one will be tool 3 offset 3, tool 3 offset 33, and right now I'm touching off the part-off blade. So I'm touching it off on this corner to be tool 5 offset 5. So I've actually just done that, and now I'm going to jog this over to the opposite corner, and what I'm going to do on my probing page here is I'm going to go down and I'm going to do tool number 5, offset number 35, and I'm going to change this tip direction to what makes sense for that tool, which will be that. So now my tool 5 offset 35 will use the opposite corner of this part-off blade as its offset for the rear subspindle. So let's go ahead and touch that off. You guys probably can't see that. So that's basically how you use your multiple tool offsets in order to do work on both spindles with the same tool location. All right, guys, so looking at this code, I can already tell that there's a few problems here. So if I go down to our subspindle grab, and we look at some of the code here, so we do a subspindle grab here, so it goes up to our feed position, it unclamps the secondary chuck, which is what we want, turns the air blast on, and then it turns it back off after it rapids up, and then it feeds up to the clamp position, clamps the secondary chuck. So that's good so far. And then it unclamps the primary chuck, and then it feeds to its feed position, and then it goes rapids back to its work position. So I've actually had to change this to 16 instead of 14 because with my grooving tool I didn't have enough travel in the z-axis. So that's why that number is 16 and -16 instead of -14. But then it clamps the primary chuck again here, which we don't want because there's no part in that chuck, and it has to sit there and wait while we do the rear spindle work so that we can basically put the part back in the main spindle. So we're going to delete that line. So we'll go here to the next spindle grab routine. So here we are again. So this starts to get a little funky. So you can tell that this post is designed to only pick off a part, and that's basically all it does. It either picks off a part or it pulls the bar out as a bar feed function. What we have here is it's getting ready to go put the part from the rear spindle back in the main spindle, but it's unclamping the secondary chuck. We don't want that because the part's in the secondary chuck and it would just drop it on the ground. So we'll get rid of that line. And then it feeds up, and then air blast, and then it clamps the secondary chuck, which is already clamped, but we actually need to clamp the primary chuck. So we need to turn this from an M110 into an M10, and we'll change this to primary. Okay, so that fixes that. But then what I noticed, well, actually we do our little parting thing, parting tool path, and then we have our subspindle return again. And this one's all messed up too, because even though I have in the little menu for the subspindle return to keep both chucks clamped, it's still unclamping the primary chuck as if it's trying to either pull the bar feeder out or feed the bar out, or just pull a part out of the front chuck. So we need to get rid of that. And it should already be clamped, so that doesn't matter. So this is cutting the part in half and keeping both parts in each spindle. And then it goes and starts doing its finish passes on those. But what I've noticed is a couple things here. So I have in the post a Z -10 as our G53 home position. So this is like a safe tool change position for my machine. And it uses it sometimes, but other times it completely ignores it. So let me find one for you here. So like here, on our spindle return, on this little tool path, for pulling the spindle back to its work position, it sends the turret back to its Z home position, which is not what we want. So this is Z, it should be Z -10. And it's done this in a few places. So I'm going to go through and find all those. There's another one. So all of the rear work spindle, there's something messed up in the post because it's ignoring our Z home position, and it's just putting an actual Z0 for the home position in there, which is an unsafe tool change position, especially with that B-axis forward. So this should be Z -10. And I believe it does this on all these tools. So there's another one. God dang it, I keep hitting this. Sorry, I'm working in the dark here, so. And then, let's see here. So then we're doing the groove. And then this is actually my manual input. So this is my move to a safe position, and then my MO for clearing chips. But what I noticed was that I tried to run this program in graphics on the machine, and it would alarm out with an over travel. And that was because it was not changing back to our, so it was still in like a mirror image spindle code, which is a G14. So I had to put this G15 in to cancel that mirror image code before this spindle grab, because even though I'm using G54, it was still using the mirror image code. So everything was backwards, and it was alarming out from an over travel. So I had to force that in there, which is kind of silly. I think it might just be because I'm doing the spindle grab instead of like another tool path, because I did notice that down, so that's the parting. So when I go to do this next facing operation in G54, it puts the G15 in there. So I think it's just something funky with the code, with the posting code. But all this stuff is stuff you guys got to watch out for. So it really pays dividends and keeps you from having to call your HFO and get your machine realigned by paying attention to these codes, so you don't get major crashes. So I think that about covers it. I know there's a couple more of these I need to go find. So I'm going to go back through this and make sure all of this stuff's good. There's another one. So just pay really close attention to what's going on here, and run it in graphics if you can. See if you can figure out why things are doing what they're doing. There's another one. Just be really careful, because these posts are not 100% in Fusion yet. I know they're working on it, and I'm sending notes to them on all of the problems that I run into. So yeah, so I'm going to go back through this, make sure everything's good, and then we'll hopefully get this thing running on the machine. One other thing I just noticed is that on this second sub-spindle return, so after we've parted off, it's not even sending it home for some reason. I think that maybe their post is a little bit funky. I'm not sure how those posts exactly work, because I'm not a post coder, but this is only sending it back to the B feed position, and it's not actually going all the way back to our work position. So I'm gonna have to fix something here as well. If we go up and look at our previous, right there, okay. So this one, after this wait code, so this dwell, I have both of these lines, and that's exactly what it should be doing again. I'm not sure why it doesn't post it correctly. So there's definitely some funky stuff going on in this post, so you got to be real careful. So right after that wait code, it looks like it's also not doing the spindle synchronization turn off, which is also not good. So I'm not sure what's going on there. The post is definitely funky. So I'm going to look through this. I'm going to copy some of this code here. So after that initial dwell, it looks like it's waiting for the chuck. That one probably doesn't need to be there. That's just cooling off. So that should work better. Okay, so there's one more problem. So a bunch of stuff going on in this post, so be careful, guys. All right, guys, I think I got this going now. I ended up scrapping one part, getting this going, but I think I got it all sorted now. So there's my blank material in the front spindle. This first operation is going to be facing this, turning this, and then the next operation will be boring, and then we'll get into some live, or the groove, and then we'll get into some live tools after that. So let me just go through this quick. I'm not going to be able to really show you guys anything because, one, my light's dead in the machine, and two, I don't have a waterproof way of filming at this point yet. So I'm just going to show you the end results here. So there's our face and turn. Next will be bore. So there's the bore done. Next will be groove. There's the groove. Next will be live tools. So there's the live drill just got done. See the hole there. Next operation will be reaming those same holes. All right, so ream the holes. Now we're going to bring the sub spindle up. Let me clean this window off so you guys. Okay, so some sub spindle's about to come grab that part. Clamping, unclamping the front. Off she goes. So now the part's clamped to the rear spindle at our work position. Next operation will be turning this, boring this, doing a groove on this. There's the turn. There's the bore. Next will be groove. There's the groove. So now we're going to hand it back off to the front spindle. We have an MO right here in the program to clear. And let's see. Part off goes into its parting position, so it's out of the way. Spindle is synchronizing. Now it'll part off. So there it's cut off our part. So we have a half finished part in each chuck. Now it's going to go finish the front side, finish the rear side. There you go. 2 complete parts. There's our holes. So that's 2 complete parts in one operation. Total part time is 4 minutes 36, and that's with optional stop on, letting the spindles ramp down, ramp back up, all that kind of stuff. So that's about it, guys. So I guess moral of this story is be super, super careful with fusion posts for lathe. I would say that it's almost mandatory to understand G-code to get something like this to function properly in fusion. I know that they're working on the posts and everything, but you know, it's not quite there yet. So be very, very careful, but it is possible. It's a pretty damn efficient program for those. I could probably speed it up a little more, and it's probably actually a little bit faster than that anyway, without having an optional stop on. But yeah, that's about it for today, guys. If you like what you're seeing, again, subscribe, like, comment, ask questions. That's about it for today, man. I'll talk to you guys later.